All right, so as Jamie mentioned, I'm a certified Mathematica trainer. I've worked in academia for many years, and I've talked to people so far quite a bit where they're experimenting with Mathematica online and getting a feel for what it does, but especially making that transition from desktop to putting things on the web or doing new things that they could never do with Mathematica before because this technology opens up new avenues. So let's get started. Okay. All right, so I think in terms of the benefits of Mathematica Online, a lot of times it boils down to workflow, and that's what I'm going to focus in on a lot today. Where if you want to take notebooks and share them with a broad audience in some way, shape, or form, there's several ways to do that. But a lot of a lot of the benefits to Mathematica Online, it boils down to this workflow. So far, I've seen two broad types of workflows when people use Mathematica Online or Wolfram Cloud. The first is called more of a deployment. So the idea is you are embedding mouse-driven applications into existing web content. So meaning if you've got a website that is a course website or a research website or just a personal interest website, but you want to embed some sort of live calculation in that into existing web content, that's a great fit for what we call a deployment. Um, Wolfram Language can now do full web forms, so I'll show this in a little bit, but this takes the tedium out of switching back and forth between us versus HTML versus other web technologies, just to build a web wrapper for some sort of calculation or something that you want to share. So there's a very easy, convenient way to do that now. Third type of deployment I've seen a lot is notebooks. Those of you familiar with CDF, this is similar to CDF, but with the main difference being that things live in browser instead of living as a local file or a file that needs a local piece of software to run. So a typical notebook that lives as a deployment, it would have text and formulas and graphics and calculations, so all the usual things that notebooks are good for. The live calculations, though, are mouse-driven applications. So again, it's something where people read this full document, but then they can do some live calculations with a slider or something like that. On the other hand, or on the other end of the pool, there are what we call just sharing full notebooks. So while a deployment is more sharing a finished application or a finished project, sharing a full notebook opens up the authoring environment and is a much more live, editable, Mathematica-like Wolfram Notebook environment. So if you share a Wolfram Notebook with other Mathematica Online users, they can change the inputs, they can append to it. It's a living, breathing document. So this is nice if you're collaborating with someone. It's nice if you're sharing courseware. It's nice if you want to give someone a start of a project and then have them append to it. It's also nice, I mean, I'm going to talk about sharing and collaboration most of the time, but just the idea of using Mathematica Online where if you go to a machine like a guest machine or a collaborator's machine, they don't have the full Mathematica on that machine. It is really convenient just to hop over there and log in and change and work in a full notebook without going through the prerequisite step of a full installation. Um, Other things for full notebooks, I mean, there are specific viewers and collaborators and ways to do this. So unlike a deployment where the delivery mechanism is usually pretty straightforward. It's a website, whether it's a third party or our website. There are more workflows and more workflow possibilities that you will want to do with full notebooks. So meaning you might want to give a notebook to someone but have it not be editable. Or you might want to give a notebook to someone but force them to create their own copy so that they can append to it, but they don't disturb your original work, especially with courseware and especially with things. On the other hand, with a research team, you might have a team of 3 or 5 people. You're each building part of an algorithm or part of a program, and you all want to pop in at different times and append to a different section of the same notebook. But everyone can see everyone else's work as different people are popping in at different times. So when you start to talk about full notebooks, the workflow and what you want to do and what you expect to do out of that is different. So I'm going to delve into that a little bit as well. But this is a broad outline for how this technology is used and what I'm going to show today. Okay, so let's start with model building in Mathematica. So when I talk about deployments, so I'm going to start with deployments. When I talk about deployments, we're just going to quickly build something here to actually deploy. So if we start with something like importing a logo, so we're going to import this off the web. I'm going to define a variable called logo. This is just our Wolfie logo off of the Wolfram website. So if we import that and then we say, let's blur that. So let's, let me just blur that. That's the beauty of Wolfram language. I don't need to explain any further of what this does. It's pretty straightforward what it's doing. So in terms of model building then, we might want to take the next step and we might want to say, instead of blurring to some sort of constant second argument, we can wrap a manipulate around this blur, so we are increasing or decreasing the amount of blur that we apply to this image. So manipulate has been around a long time. This is not the focus of this this actual talk, but manipulate is something that a lot of users make heavy use of across fields, across academia, hobbyist projects, industry. So this is why I'm starting with this as a representative example. So when we blur a logo like this, the next thing now that I want to talk about in the way of deployments is how do we share this as a deployment and really start to get this on the web. So if we start with blurring logo and we add a little bit here, save definitions true. So that what that means is we are storing the definition of our variable in the GUI itself. We can start with that. And then there's a nice new function in Wolfram language called Cloud Deploy. So when I run Cloud Deploy, instead of getting a GUI back, what I'm getting is a URL. This is doing a lot of things at once. So what Cloud Deploy does is it takes my application here, albeit a very simple one, with one function, but it's taking my application, it's copying it to the Wolfram servers. So my custom code is copied to the Wolfram servers. It links it up to a Wolfram language kernel on Wolfram servers. It generates a URL. It gives me a /objects/ encoded URL here. So I get a URL that's very specific to my particular example. And then there's another argument, a second argument to Cloud Deploy where I can specify permissions. I'll talk about this a little bit more when we get into notebooks, but here in this case, what I'm just saying is anyone who has this URL can go in and run this and it's open to everyone. So when I click on this, this will open on the web. This is a completely now web browser-based version. There's no plugin that's needed. There's no Mathematica kernel that's needed. You know, I happen to have, you can see here, I happen to have several Mathematicas on this machine, but it's not using any of them. So I could send this to all attendees here at this webinar, or I could send this to all my friends. They don't need to have Mathematica. They don't need to have Wolfram language. They can just go to this URL, they can run my application, and the calculations all happen on the server. So this is a very quick and easy way to share an application where it is portable, it works on any type of web-enabled device, and all the system administration of getting it on the web or hosting it or doing something, that all just takes care of itself, basically. All right, so once you have something on the web, there's a lot of things that you can do with it. I mentioned portability before. One thing that you might want to do is embed this in a course management system. So I just chose one, I mean, not at random, but kind of at random, where you can iframe in web content into a course management system, a lot of times there is a GUI to do that in a course management system where you just say, I want to specify a URL, and I either want that to open in a new tab, or I want that to be embedded right here. So in this case, you can choose embedded, and then it just works within your CMS. This is a screenshot, so I can't move the actual slider here. It's just for demonstration purposes. But same story on something mobile. So if I were to send this URL to someone and they go on their phone and open it up and take a look at it, they can move the slider. It all works on mobile just fine. It all works on tablet just fine, where they can move the slider. So again, the portability of putting live calculations that are created very, very quickly and very easily, but having that accessible across any web-enabled device, it is really, really useful and really interesting. And once you start to delve into this world, you get a lot of new ideas. There's a lot of new things you can do outside of a full, complete Mathematica or Wolfram language installation. All right, so the next thing now, so I've used manipulate to create a deployment where all I've done is I've wrapped manipulate around it and it made a slider. Web forms are the slightly more general version of that. So instead of it always being a slider, what we're going to do is we're going to make a web form with some input fields, some more flexibility, some more options for the user of the application to change things and to do things. So again, the main way to do this is cloud deploy, but instead of manipulate, what I'm going to do is use a function called form page. Form page asks what kind of input you want in the form, and then it is what calculation you want to do with the form. So here I'm saying the input is going to be a PNG file, and then we're going to take that and we're going to blur that file. Blur that image, blur that PNG image. So when I run this, I get a cloud object again. Instead of there being a slider, again, this builds an entire web interface. There's a way to drag and drop or click and get an image, and then we hit submit for that. So I'm gonna scoot that down just a little bit and go back to this. There we go, okay. So now if I drag my Wolfie from the desktop, so I drag that right into the web form and I hit submit, and now it has blurred the image and it's returned it. And again, this is a self-contained program now, so I could send this to anyone. They can take whatever image they want and upload it. Doesn't have to be Wolfie, it can be anything. And then it blurs that image and gives it to them. So again, this is a slightly more general version. It's not hard-coded to just one image. It's now an application that's flexible enough to accept any image. Next thing that we can do is we can expand this further, where instead of the one input being an image, we can have a second input where we can increase or decrease the amount of blur that is applied to this. So when I run this, instead of there being one image file input, there are actually two inputs here. So again, I can drag my image. This is what I want to blur. And then I want to apply a lot of blur to this. So I'm going to submit, and then I get a lot of blur. If I want less blur, I can run it again and hit submit. And then we can hardly notice there's a very subtle blur that is applied there. So this is just a quick example of multiple inputs here. So now I'm actually controlling what image my custom program operates on, and then I'm controlling a parameter of the program itself, of the actual, algorithm is a little bit too strong of a word, but the algorithm that I'm defining here, the program that I'm defining, I'm actually changing the program itself, or the user can change both of those. So that's pretty neat. It's another level of flexibility and level of control for the users. So far we've done images and just applying to images. We can also do this with Excel files. So if we do, oh gosh, we've pasted this in. Okay. I seem to be having technical difficulties here with the presenter tools. That seems to be pasting in a weird spot. Anyway, there are several ways that you can expand web forms. This example expands and goes to a spreadsheet. And so rather than doing an image, you can do a spreadsheet, but the web forms are flexible. It's not just images. That's the meta point I'm hitting here. But I'm going to move on and show a more involved example instead. Okay, so when people work in Mathematica or in Wolfram language, people get very used to a nice notebook workflow. So I'm going to highlight a few examples here from a Wolfram blog from one of our image processing developers. This is a typical workflow where when people are building up visualizations or building up course examples or building up something that you want to explore, there is a nice bit by bit buildup that you can do in a notebook where you can explain things progressively and it's all outlined very sensibly in a notebook. So in this case, what the notebook is going to do and what the example is going to do, we're going to start with this image, which is like a slide, like a cell slide here, where we start with this image, and what we want to do is count these cells in the image. We want to know how many of these are. There's several ways to do this, or several reasons to do this. So you might be working in a research group where you are a very good Wolfram language programmer. You're working with a lot of different technicians where they don't want to dive into the language, but they want to use a program that you have created and developed. They don't want to install the full Mathematica. They just want to take 20 of these cell slides per day and count them. That's what they want to do. So in this case, what we're doing is building up a program that does that, and I'm going to contrast the notebook way to do that versus a deployment. So starting with a notebook, we can define this as a variable. So we've got that image represented here. Then we can start to do some segmentation analysis. So we're starting to delve into the image processing functionality in Wolfram language, where we can color this black and white to more easily count the cells. Whoops, I've gone ahead here. Sorry, I need to make this just a smooch smaller here. There we go, that's much better. Okay, so now we can make this black and white to start to do some segmentation analysis. We can start to color the different unique areas. So here what we're doing is we are counting the major unique regions. This takes a little bit, I guess. But what we're going to do is take all of these different regions that are different size and we're just going to color them differently. There we go. Okay, so now we can see there's a unique color for each unique region. So now we're starting to count the cells. We're starting to visualize this. And then now what we can do is start to label and really start to visualize this. So here, instead of a different color, we're going to give each a different number and actually number the cells and put a circle around them. So now we can see our little program does count this, does not count some of these cells in the corner. So then we can refine and figure out exactly what we want our program to do. So we're headed in the right direction here. The other thing that you might want to do is some statistics. So once we start counting things, you might want to do a histogram where we simply look at the pixel counts and see what are the common regions where there's some outliers of pretty big cells, some outliers that are pretty small. A lot of them fall in this region, but some sort of pretty regular pattern here with a gap there. So scientifically that might mean something, and it might be a real nice discovery, basically. But big picture, this is sort of the end of a really nice notebook workflow where we are in local Mathematica, we're building up a computation step by step. What we have arrived at here is a nice set of examples that counts these cells and then gives us a nice histogram where it's a nice visualization. So let's compare, contrast that with a deployment. So if we want to give this to someone that does not use Wolfram language, does not have Mathematica installed, doesn't really do much of anything with the language or hasn't gotten into it yet, what we can do is wrap all of what I just did into a form function. So this looks like a lot at first glance, but all of this stuff here in the middle is precisely the same as what I just did in the notebook. So if you want to make this transition from a local notebook into a deployment, the transition is a lot of times fairly straightforward. So all I've done is wrap this into one uh, compact and compound cell, sorry, that's the word I'm looking for, where I have all the different calculations separated by a semicolon to suppress the output in parentheses here, and then I've wrapped form function around it. So form function is going to allow us to upload a PMG file of the cell culture. We can have a second parameter that adjusts the actual histogram. We're going to deploy it to the cloud. We're going to make the permissions public. And so again, it looks like a lot, but really it is precisely the same as what I was doing before. And when we run this, so we get this spot with the PNG image. There we go. Let me drag this off the desktop. So now I've uploaded this cell culture. I can adjust the bin width for the histogram. So I'm specifying the quantity of pixels that I want the bins to be for the histogram. And I run this and the same thing is happening. So when I deployed this to the cloud, it took my 10-line program, it copied it to Wolfram servers, it linked it to a Wolfram kernel. So now I'm in Wolfram Cloud /objects. This is my own URL. You can send this to anyone, and then they can upload their cell slide, run the algorithm. They get the numbering, they get the histogram, and it's a really nice little dashboard for them to run this algorithm and really understand what's going on with their scientific experiment. So I would say that a lot of times when you see cloud deploy and when you see it, it is in relation to manipulate. But I include this example just as a good way to show how this scales. So rather than just working with one-liners, this can work with a very nice custom visualization that does something really useful. I mean, something useful in the real world where you could build up this algorithm and give it to people, and it's a nice piece of software for them, basically. Okay, so in terms of deployments, I have talked about wrapping Cloud Deploy around to manipulate, and I've talked about web forms. In both cases, we are using Wolfram language to copy things to our servers, and we're using Wolfram language to put a web wrapper around our program, and it's hosted on the Wolfram websites. There are other cases, and especially if you are a programmer by trade, there are other cases where you might want to mix and match languages, or you might not want to use Wolfram language as the creator for your actual program. So rather than using form function or form page, you can switch to a cloud deploy of what we call an API function. So this creates something a bit different. So this is now a RESTful API that you can now access and take a look at. So one way to access this that's pretty simple is just to take this URL here and do $x = 5. So when I run this, this will open a browser and it will run my API with an input of 5. So all my API does is it accepts an integer and it squares it. So in terms of what this is actually doing, we get 25 back. So again, it's a somewhat simple example, but this is somewhat flexible, or pretty flexible as well, where if you want to integrate this into a different language, so rather than referencing this just as a pure URL with a question mark, there is a function called embed code. So switching from Cloud Deploy to embed code, and what embed code allows you to do is it gives you a wrapper for a lot of different languages to reference this API. So if we take this same API, which is just squaring in an integer, and we say, give me a Java wrapper for this, what we get back is a lot of Java code. So the core of this, again, is this URL where it's a wolframcloud.com/objects, my custom URL here. But then this is a bit of Java code that I can plop into a program. And when I run this, the program hits our servers, it passes whatever input parameters you define in your Java program. Our servers run that, it returns it, but it returns it, and it's a way to embed our code into whatever language you are using. And again, I'm describing things in terms of Wolfram language functions, which is always, it is a habit of mine, but it's again, embed code does just what it says it does. It embeds code. If you want to embed in languages other than Java, we have several that are defined and built in. So something like R or PHP or JavaScript, Java, HTML, so web languages, but also things like Scala, Visual Basic, Swift, more app development, something like that, or Android, or lower levels, C++, C#, etc. So all of these embed code environments are second arguments to the embed code function, where it gives you that wrapper to call the API function, but the wrapper is specific to these languages. So I'm showing Java, but there are several languages that are available depending on what you're doing and what projects you're doing and what languages you know. Okay, so that's a good crash course of deployment. So I mentioned at the beginning, deployments are great for finished projects. So if I'm writing a visualization or a simulation or a model or an API, something that is fairly specific, a finished project, deployments are great for that. You can also, though, deploy full notebooks. So rather than this being bite-sized web forms or bite-sized manipulates that you embed in the web, when you deploy a full notebook, then you get all the nice examples and explanation and format of a notebook. So this is one of my favorite examples. Stephen Wolfram created this. It is a cloud notebook on the central limit theorem. It is fairly long and fairly involved. It's a good real-world mock-up. This lives on wolframcloud.com/objects. So this is a deployed notebook where I can look. There's some Wolfram language code. There's some visualizations. There's some different examples. There's an embedded manipulate here where I can move the slider and, oh, there we go, okay. It's taking a little while for this to load because I'm doing the screen share at the same time and doing audio at the same time. But now when I change this parameter, what I'm doing is increasing or decreasing the sampling of random real numbers and creating a histogram of that. And so it's a nice example of how the histogram smooths out with a higher quantity of sampled random real points. But anyway, zooming out again, this is a good example of something that I could send to colleagues or Stephen Wolfram could send to me, where I could read this and learn about the central limit theorem. I can read his explanation. I can see his calculations, which are all pretty straightforward. I can look at this, manipulate and play with this myself, so it's very engaging, and then work through this to really understand this. So this is deployed as a cloud notebook. So how did he do this? So I recreated his steps here. I don't know precisely how he did this, but recreating his steps, a lot of times when you want to deploy a notebook on the web, many times you're starting from local Mathematica, and there's a really good connection and interchange between a local Mathematica installation versus Mathematica Online and getting things in the cloud. So if you start from a local Mathematica file, you can go to File and then Save to Wolfram Cloud. So if you're logged into local Mathematica, it's the same login as Mathematica Online, and there's shared cloud storage. So if you save to Wolfram Cloud, what that is doing in a nutshell is taking your notebook and putting it in that shared cloud storage. Then if you log into Mathematica Online, there are nice GUIs, drop-down menus to publish notebooks. So once this central limit theorem notebook is uploaded and you log into Mathematica Online and open it, you can click on the Publish drop-down menu, and then there are some choices where you can automatically assign a URL, you can allow access, allow anyone access, you can password protect it, and then you can make the controls interactive. That means the slider that I was moving that sampled more or less random real numbers, that's live for whoever gets this URL and whoever wants to run it. And then when I hit publish, I get a URL, and it is the URL that I clicked on to start this example. So if you've got notebooks that you've created in local Mathematica and you are especially if you're familiar with the CDF technology. So if you want to do something that is like CDF, where it is a document that you want to send people with some finished applications, some sliders, but available to a wide audience, whether they've got Mathematica or not, or Mathematica Online or not, this is a great new way to do this. In terms of advantages over CDF, I think CDF is great because it is an installation that includes a big chunk of Mathematica. So if you collaborate with people and send them a CDF file, that's a really cool way to do it. The big advantage here is the person running your example does not need to install CDF. The uptick or the prep to look at your example is pretty much zero. They just click on a URL, they can look at it immediately. The barrier of entry or the prep that they need to do is pretty minimal. That's a big deal when you want to grab someone's attention or have them read something. If you just want to send them something and say, hey, read this for 3 minutes, you don't want them to spend double that installing software. This is a big portability benefit where people can look at this and pop in very easily and read what you've done. But anyway, this is the workflow to take a notebook and publish it where the full notebook itself is a deployment. So then that leads us to the original division that I made between deployments and full notebooks. So once you're looking at a full notebook and once you're looking at something with inputs, it is awful tempting to want to go in and change this random real input and rerun this or append to this or do something with this. And that's really where deployments end and full notebooks and Mathematica Online begins. So in addition to the publish drop-down menu, there's a share menu. So if you are collaborating with other people that have Mathematica Online, which many people do these days, it is starting to be added to campus site licenses in a pretty mainstream way. And it's also starting to be the default yearly maintenance for licenses as well. So a lot of people now, whether you realize it or not, a lot of people have access to this licensing. So sharing is different than deployment. So deployment, you get a URL back, you send the URL to people. Sharing, you are typing in Wolfram IDs of other Mathematica Online users, and then they get access to your notebook. So there's a drop-down menu where you can say your notebook is private, you want to share with some people, they can view, they can edit, you can add a personal message, and then an email automatically gets kicked out to them that prompts them to log into Mathematica Online, and they can click on a button and say, great, I can look at your example. So there's a nice mouse-driven GUI way to do that in Mathematica Online. However, if you're collaborating with quite a few people, there's often a need to well, if you're collaborating with a lot of people, there's a need to not retype Wolfram IDs over and over and over again. That's essentially where I'm going with this. So especially if you're teaching a class. So if you want to have a course roster of 50 students and you want to share a different notebook with them every week, it is tedious to retype those 50 names into the share dialog every time you want to share a notebook. So what we've done here is gosh, why is this pasting at the end? Okay, I'm just going to sort of ignore this and go on here. So what we've done here is created, and I say we as the Wolfram developers, I'm not a Wolfram developer, but what is built into the Wolfram language is a whole system to share, but share at a language level. The entire advantage to this is workflow and quantity of people. So if I run the command create permissions group here, I can give it a name, Kelvin Collab, and there are 2 members of this group. 2 members is not very exciting, but what this could be instead is your class roster of 50 students, or it could be 20 collaborators on an NSF project, or it could be 20 people who work at your company where you want them to look at some visualization. But you can list out as many names here. Once you create this permissions group, it is defined in our cloud. So this name is defined and is stable. And then you can run the command permissions group just to see at any time. So if I created this permissions group a long time ago, oh, I'm sorry, this is the actual output, not the input. So if I want to do something with this permissions group, I can start to query who's in the group. I can add people to the group. I can take people out of the group. But what we want to do then is take this permissions group and start to use it in a similar way to that share drop-down menu. So what the share drop-down menu did was you start with a notebook and you type in a Wolfram ID such that they can start to use it. Set options is the language way to do this. So instead of logging into Mathematica, going in, navigating to that notebook, opening it, clicking on a drop-down menu, instead of doing all that, you can just do set options of this cloud notebook. So this is a optical illusion notebook that I've created somewhere along the line. It lives in my Wolfram Cloud account, so I reference that as a cloud object. And then earlier I was doing permissions goes to public. That means anyone can look at my websites, the things that I was creating. Here I'm specifying this permissions group and I'm saying anyone can read and write to this. So both of my 2 members here, where was I? Yeah, so Kelvin M and Kelvin underscore, each of them can open up this notebook. Each of them can read, but both of them can actually write and write to the same notebook. So this is good for a research group where, and again, I mentioned this in the beginning, but a research group where if we were working on this project, there were 3 to 5 people each building a separate piece of the project. Everyone needs to see what everyone else is doing. Different people are popping in at different times, but we are all essentially editing the same notebook. This would be the way to do that. It's a very handy way to do that. Now, conversely, if you're teaching a class and you want to assign something to students where it's more of a project, this is pretty much the last thing that you want to do. So this is the polar opposite, where this would be a notebook where it is a start of a project. It is the setup to an assignment, but the idea is that students each complete the assignment. Maybe they turn it in, maybe they share it back to you, maybe they don't. But in this case, we can set the permissions group where this would be a course roster. We have set it where they can only read my copy, as the instructor, my copy of the file. So they cannot edit the template, the starting point of the assignment, which is very important. And then the second thing, there's an extra argument here called autocopy. So when students open this notebook, that forces them to create their own copy in their own cloud account. So if this were an assignment that I shared with 50 students, they each open it up, they each then create their own corresponding copy of this. They can start to append to it, they can complete the project, but none of the 50 students can see what the other 49 students are doing, and none of the 50 students can overwrite my template that I'm sharing with all the students. So in this case, it really forces students to do their own thing, which in a course setting especially is extremely important. Otherwise, um, it would be essentially mass chaos if all the students were writing over each other and seeing what each is doing and things like that. So set options is very useful where if there's a larger group and if you want to do this repeatedly where it is this blur logo notebook this week, optical illusion next week, another one next week, you can set up as instructor or as the initiator of the share, you can set up these commands and then just run them over and over and over. So my permissions group persists as long as I have a cloud account, and maybe next semester I might change that group based on a new group of students, but for the most part, I can just rerun this based on the next assignment, and once I've done the prep one time, then I'm ready to go, and I can share a lot of projects with students, or I can share a lot of projects with collaborators in a hurry once I've set this up once. So the repeatability is the advantage of the language, as is the groups where you can do this with a large number of students, basically. Okay, so let me show here one example. So I mentioned before that when you run the share drop-down menu, or when you run the command in the language called cloud share. So cloud share is similar to set options, but the difference is these functions kick out an email to the recipient of the notebook. So I just want to mention this briefly because there are pros, again, there are workflow pros and cons to this. So from my personal use of Wolfram language, this is wonderful for me. So if I've got a collaborator and I want to share a notebook with them, or if I have a group and I want to share a notebook with them, this generic Wolfram Mathematica message where the recipient gets this and sees Calvin Misho just shared this with you, click to view this file. The recipient logs in as a Mathematica Online user, and then they can look at the file and append to it and work with it. That's wonderful. There are other cases, though, especially if you're teaching a course, where you don't want this auto email to go out. You might want to customize this. Set options does not kick out an email. So if you want to have that URL linked in a course management system or a learning management system, and they get the link that way, basically, where the CMS LMS gives them the link, that's a good way to do it. So set options is a good way to do it. You can also do things like use functions like send mail. So you can use set options to give a group of 50 students permission to access a notebook. You can turn on the auto copies so that they're going to make their own copy. But then if you want this message to say, this project is due September 5th, there are no extensions, I expect X, Y, and Z, take a look at your syllabus for more details. Like if there's something that is very specific and very course specific, where this catch-all message simply will not do. It's not specific enough. There are ways in language to use send mail where you can send a URL to that group of 50 students. Again, if you've got a permissions group, you've got their emails, it's very easy to shoot out an email to all 50 of them with that URL with very specific instructions. So in terms of communication, this starts to be a subtle topic, but I want to just at least start you down the path of thinking about once you get these things, once you get full notebooks on the web and once you start sharing with students, that experience of the right communication and the right instructions coming along with the notebook, that becomes very important. Or the right wrapper for your research collaborators where you want them to do something specific. So in this case, they don't learn what part of the project you want them to do, so you might want to do that. But anyway, big picture meta point here is some of these functions kick out an auto message, some do not. Both are useful, and likely both are useful in different cases, basically. Okay, so that basically brings us to the end. So in conclusion here, local notebooks are still very useful. As a company, Wolfram Research is not phasing back or phasing out local notebooks. Mathematica as a local installation and Mathematica Online as a cloud installation, the pair of them will still be far more useful than either of them individually. Um, but this new way to get deployments on the web and notebooks on the web, it opens up new workflows. It's good for web-centric collaboration. Um, I've listed out my email here. If you want to know whether your organization has Mathematica Online, please do feel free to send me an email. I'm probably going to likely introduce you to the person who knows the answer to that question, but um, when you're watching this, I can anticipate that that might be your first question, which is, do I have a login to Mathematica Online? Because a good chunk of what I've shown here really does need some sort of cloud product to work and to work and to make it sing for your classes.